kick it off really quick. For anyone I haven't met, my name's John. I am on our DevRel team here. So get to do a lot of our events, paper readings, and content, and basically learn about the new stuff that's coming out, become an expert in it, and then try to teach it to as many people as possible. So that is my side. Sally, I'll let you introduce yourself as well.
Yeah, hey, y'all. I'm Sally Ann. I'm part of the product here at Arise. One of the products that I lead is our AI assistant Copilot. So I'm always kind of trying to learn myself as somebody who's got hands-on project that they're working on. I do these paper readings a lot. I love kind of learning, same as John, about the latest and greatest, and then coming and talking about it in this forum. So I'm excited for today's talk.
All right. And I've seen a lot of people jump in pretty quickly here, so I'll go ahead and share. We might have a couple come in as we're getting going here. I think hopefully everybody got the memo here, but we did a little bit of like a last minute change about a day or so ago to what we're covering for the paper reading today, where we had planned to talk about some of our own research, which we'll probably do in the future here. But we've had a big week of announcements in the AI space. So we wanted to kind of cover some of the stuff that is happening right now, some of the stuff that's ongoing and has recently been announced. So we're going to deep dive into some updates from Deepseek. We're in the middle of their open source week, so we'll talk about what that means and what some of those updates are. And then we'll also go through some updates from Anthropic as well around some of their new Claude model, and then some new product they have called Claude Code, which is in a research preview. So we're going to dive into those to kind of keep everybody up to date with what is happening, what's going on right now, and what's happening in the space. So if you have questions throughout, as always, throw them in the chat, and we'll answer them as we go, because we're going to kind of go through really like 5 different kind of areas here and dive into each of those. Cool. All right, let's kick it off and get started here. So we're starting off with Deepseek's open source week. So if anyone's not familiar, Deepseek is doing open source week this week, where they're releasing a new open source repo every day this week. So we've had 3 so far: FlashMLA, DeepEP, and DeepGem. And so we'll talk about each of those and what's coming with those. But I'll call it out too that we're not even through the week yet. So there will be 2 more releases that they're having tomorrow and the next day. So we're kind of doing like a little bit of a midpoint check-in here with the releases that they've had so far, and we'll go through what each of these looks like. So start off with FlashMLA. So FlashMLA, what this is it is a hyper-efficient decoding kernel for Hopper GPUs that's been optimized for variable length sequences. So what does that actually mean? What this is in this case is, for anyone who's not aware, there's kind of a decoding step that happens both during training and inference, basically anytime you're using an LM to turn the outputs of all your kind of transformers and the logic there into the next predicted token or whatever the output might be from there. So there's kind of a decoding step that has to happen whenever you're using a model. And there are techniques to do this. There's one called flash attention, which we'll talk more about in a second here, that really significantly speeds up this decoding process. And that's been used in a lot of different kind of libraries and applications, which again, we'll talk about more in a second there. And FlashMLA is kind of Deepseek's version of this flash attention approach, where they've optimized it even further for specifically these NVIDIA Hopper GPUs, the H800s, the H100s, and they've been able to make it both faster and more efficient, and then also handle longer context or more variable context very well. So if you have applications that are heavily language-based or are using a lot of text or something like that, it's more optimized for that approach. And so just in comparison really quick, and then we'll kind of discuss it a little bit. I mentioned flash attention is sort of another very popular version of decoder library here. The flash attention has been used in PyTorch, it's in Hugging Face transformers, it's in Microsoft's DeepSpeed library, a few others as well. And to this point, it was sort of one of the fastest options out there. But when you compare it to what FlashMLA has been able to achieve, it's been basically a 20% increase on the fastest teraflops per second kind of rate and decoding rate that flash attention was able to provide. So it's already been this kind of 20% boost on what is kind of considered as one of the leading techniques in the industry. Again, it only works for these H series GPUs, the Hopper GPUs on NVIDIA, but it is kind of a very big boost that we're seeing from there. Sally, and I'm going to ask any kind of thoughts or commentary. Like, do you feel like this is something that people are going to incorporate into existing libraries pretty quickly? Do you feel like who is this sort of for in your mind with this kind of faster approach?
Yeah, I mean, I feel like this is really going to be for our developers, the ones that are kind of trying to maybe train their own model. I think that I'm curious to see what they do there and allowing people to do that. But that's what seems to be the most interesting about this, just because of those improvements in training. Like it's obviously very impressive there. Um, it's also interesting. There was a note in the chat there about like which chips this uses, and you noted there that it is only for the NVIDIA is it the Hopper GPUs there?
Mhm. Yeah.
Which I think is an interesting choice as well, because at the beginning it kind of seemed like they were shying away from all the NVIDIA chips. So it's also interesting when I was reading this that they made a choice to exclusively use those.
Yeah. I do feel like NVIDIA's sort of CUDA language and approach, like kind of maybe is something that they seem to be experts in because they really like a lot of these announcements are pretty focused on the H series chips from
Yes.
NVIDIA. So it seems like they've gone really deep into like that area too as well.
It seems like at least that's where they're trying to invest.
Yeah. And they do have a note in there too. I mean, in the spirit of this all being open source too, they have a note in the repo that's talking about, hey, if you want to make contributions, if you want to apply this for other kinds of chips, other architectures, then like please do that. And there's actually a couple that people have already done there as well too. So it does kind of seem like they've done, hey, this is what it looks like, and then they're going to rely on some of the community to kind of extend it to some other
Yeah.
chipsets as well too.
Yeah, excited to see that.
Yeah, so that's our Monday release from Deepseek is there, and it's already got something like 20,000 stars on GitHub as well too. It's like definitely been met with some excitement there. They followed that up on Tuesday with DeepEP, which in this case is a communication library basically between different GPUs in mixture of expert and expert parallelism architectures. So if you have a model that's using a mixture of experts approach where kind of different aspects of the model are stronger in different areas, and those expert areas kind of work together to get to some sort of announce or some sort of output, then you would have to have some kind of communication between those different kind of experts here. So this GPU to GPU communication. And so DeepEP is DeepSeek's library here that makes that communication even faster between these different kinds of GPUs. And so there's existing kind of domains and these techniques for how those GPUs will connect to each other. So NVLink and RDMA are both these approaches of having that GPU to GPU kind of communication that's not relying on memory to kind of save data to memory and then have the other GPU read it, and kind of adding that extra step of communication. So these NVLink and RDMA approaches basically allow you to skip over that memory step. And so DeepEP here supports both of those approaches. So it's a little bit more like agnostic in that setup that it has there. So it's able to work with different kinds of GPUs as well. And then it's also added support for 8-bit floating point operations, which is kind of smaller, more efficient operations than a lot of other libraries are focused on, with the idea being that you can have this kind of faster, more efficient communication between different experts within your mixture of experts kind of setup here. So really, again, the top line of this is that if you're using this kind of architecture, or either for training or for inference, or using a model with this kind of architecture for training or for inference, then that is going to be now faster if you use this DeepEP approach, more computationally efficient, which is actually pretty helpful in this mixture of experts approach, because it means that you can have more experts in your model. You can kind of have these larger parameter sizes and still be able to get fast responses because you have this more computationally efficient method of them working together and communicating with each other simultaneously. So I don't know if there's anything you want to add around this one, I guess. Yeah, go for it. Yeah.
Yeah, I think that this is interesting. I think it's going to help kind of scale these mixture of expert efforts. I think that kind of all-to-all communication in the past has a little bit of been a bottleneck. So I think that there's some potential there for that. So just making it more efficient to have this kind of parallelism across these mixture of excerpts.
Yeah. And I guess on the mixture of experts kind of subject, you might have a better answer than me here, but are you kind of seeing that being more adopted across a lot of different models? I guess, are you seeing that becoming a predominant way? Is this kind of jumping onto this most popular technique, or is this more like a specific area?
I still don't see actually a lot of people making it into like a production setting. I think everybody's really curious and they want to understand how they can use this because it seems really promising, but I haven't really seen anybody like land on like this is how you do it and this is the best way to do it yet. A lot of experimentation still.
Gotcha. Okay, maybe this is the catalyst for somebody
Yeah,
landing
that's what
on
I'm thinking.
the
That's what I'm
approach.
wondering if this will be the thing that kind of helps make it a little bit more accessible, a little bit more efficient to use.
So, yeah, this is the fun part about the open source side. They just put it out and then you see all the applications of it across different people.
Yeah, I love seeing it.
Cool. All right. Cool. And then the third release that we've seen from them this week is this deep gem library. And this one is kind of beautifully simple in a way. This is like a 300 line code library, but it's like incredibly useful here. So what it is it's a library that allows you to efficiently run 8-bit floating point matrix multiplications. So there's, as I'm sure most people on the call know, there's tons of matrix multiplication that happens anytime you're using LMs here. So again, this is specific for Hopper GPUs, but this is a library that you can use to actually run those matrix multiplications, and it's much, much faster. We'll look at some kind of benchmarks in a second as well too of that speed up. But you can actually see the code that you would use to like run the matrix multiplication. It's basically adding this like operation that you can then run to do a 8-bit floating point gem here, just providing 2 different tensors, and it will do that multiplication step for you. Adds in a couple kind of key features here that makes this, that kind of contributes to this being very fast and efficient. One is this just-in-time compilation method, where instead of pre-compiling the kernel that's being used for this, it's compiling it like sort of as needed, just-in-time basis there to speed that piece up. And then the unaligned block sizes, I think, is very cool. Basically, with this, what they had noticed is that if you're using certain like kind of if you have to basically use the same size kind of block sizes to do 2 different matrix multiplications of 2 different matrices here, like say you have a 256 dimensionality kind of thing, you'd have to use, and then you have like a 112 dimensionality matrix, like you'd have to use a 256 by 256 kind of block to support that. And in this case, they can actually use kind of asymmetrically sized blocks here so that they're making better computational use of the available processors that you have. So instead of kind of wasting space, basically, if you have unaligned block sizes or unaligned matrix sizes, they'll kind of dynamically handle that to essentially allow you to run more in parallel here as you move through. And I see a couple questions popping through as well. Yes, Deepseek is indeed doing very many cool things. This is awesome. Yeah. There's a question too about, has anyone found the Deepseek API or through providers like Fireworks or Together not as much reliable, either due to rate limits or downtime? So if anyone has experience with that, feel free to drop it in the chat as well too. I've been able to use it somewhat successfully. Sally, I don't know if you've sort of been pressure testing any of the Deepseek API or anything like that, or if that's really come up.
I haven't
Right.
really tried to pressure test it. I know Nick from our team has been a good amount of time, and he had pretty much good things to say. I think with all the attention that they're getting, I could definitely see that their system might be pressured a little bit more than they maybe intended.
Yeah.
So I could see that being like some growing pains that they're going through.
Yeah. One actually a note on this too is actually from this morning. One other announcement we didn't put in the slides, but they just put out a release of basically like giving you like 70% off, I think it was, to call their APIs during off-peak times. So I think that might be their way of trying to kind of like do some additional almost like load
That's
balancing.
really smart.
Yeah, to say like
It's a
we'll give
little
you
bit of a
cheaper.
hack to,
Yeah.
well, I get some time to actually figure it out, because of course, like scaling those types of resources, that takes time.
Mm.
And so that's really creative way to try to get a little bit of some pressure release from them.
Mm-hmm. Definitely.
Um,
Awesome.
yeah, I think that this one's really interesting. The focus on that like FPA computation, the idea of like reducing precision kind of while maintaining that accuracy. But something that I really think would be interesting is trying to like benchmark the trade-offs between, the different precision formats of like understanding like, okay, FPA is really great for speed and efficiency, but like, is there any like accuracy, like degradation
Mm.
as you like use like specific models? So I thought that was something interesting as I was like learning more about this. And then the other thing I'm wondering is like, since it kind of came off of the DeepEP, like did they do anything with Deep Gem, like with the mixture of experts in mind? Like, is that something that they're going to kind of continue to invest in? So I thought this release was kind of interesting, and I'm interested to see if we get some more information and benchmarks coming from it.
Yeah, definitely. I think it was this one out of the three that there was a note too that was saying, hey, like we've implemented this technique that was proposed in the DeepSeek v3 paper, noted that this is slightly different than what we proposed originally. So I do feel like they're even between that, they're iterating on some of what they've set out to do. But it does seem like they're kind of almost in a way kind of saying this is how we did a lot of this stuff, with so many people that were coming forward and saying, oh, this must be fake. Like you must have used more kind of training power, you must have spent more money to kind of do this. So I do wonder if the part of this is them being like, here's how we actually did all of it. Like here's, this all works, and these techniques were what allowed us to do it. So somewhat cheaply and kind of quickly as well.
Yeah, that makes a lot of sense too, because they did definitely, there was a lot of people out there that were saying no way. And it's an interesting, someone even made a comment in the chat there of like why do you think that they're trying to open source kind of that like secret sauce, and how does that affect their business? And I think it's always a balance of keeping open but also sharing. And I think Johnny made a really good point there of that maybe it's to try to get some people believing them.
Yeah, definitely. Cool. And just to kind of wrap this one up as well too, I pulled some of these from the GitHub repo. Encourage everyone to check out the metrics as well. But you can see like they're kind of speeding up this process of running these gems depending on some of the dimensions or like kind of the sizes basically here as they're going through. And it is interesting because for some kind of combinations here, they're actually just the same as existing techniques for this. But for some of them, they're like much faster in this case, which I think, again, this is not like my area of expertise, but it seems like some of that might be coming from some of the unaligned block sizes and things like that. So when they have less alignment between the sizes, they're able to actually show a stronger speed up basically over time. And we kind of started talking about some of these a little bit, but like some takeaways that I had jotted down here from kind of all of these releases, high level is, again, like most of this stuff is geared towards faster, more efficient processes, basically. So whether it's inference or training, a lot of this is kind of lower level libraries that allow you to speed up both of those different operations. And so it does kind of relate to a lot of what they were able to do with DeepSeek v3 and even R1 to a degree of having this very efficient training process, this very fast model process as well too. And then we kind of talked a little bit about the Hopper series GPU focus, and that's kind of what they're starting with. I guess one other point to maybe raise there that we haven't necessarily covered is that this is open source, but in a way it's maybe like a little bit restrictive because it's kind of hard to get access to an H100 or H800 as a lay user. Like it's kind of hard to go get access to one of those if you're just a regular person. So while these techniques are very interesting, I think I am curious to see how much the hobby community basically will be able to kind of pick them up and use them quickly, or if it's going to rely on some of those changes and updates for other kinds of chip architectures as well. And then this last piece is sort of just my own prediction, but because they're open sourcing this, I have to imagine that every model provider out there, every company who's building some of these tools and building models is going to use these techniques pretty soon or use their own variations of them. So in a way, this is kind of like pushing the open source side forward, but I got to imagine this is also kind of pushing the closed source side forward as well too, which is kind of a byproduct here that we'll see. Cool. Yeah. Johnny, to your point, yes, the point is an individual user can't really afford an H800, so that does kind of limit the accessibility for some. Cool. Just to cover back on a few of the comments that we had coming through, there's a question about whether OpenAI exposes the GEM API. I am not sure that, I don't think there's anything that OpenAI exposes around how they're running matrix multiplications or anything like that in their own system. So I don't think OpenAI would be exposing how they're doing that, if I'm understanding the question correctly as well. Cool. And then I have Julie noting that they have experienced downtime with the RAG app, and the RAG app tends to work better with GPT-4 Mini than DeepSeek R1. I do think there's kind of the trade-off there of like you have a little bit more reliability with some of these closed source providers, especially right now as everyone's piling on DeepSeek. So it's maybe like a selective process to use DeepSeek for some more kind of complicated queries or like your reasoning model-less queries or something like that. But it is kind of the trade-off that they're happening. Hopefully something they can address soon as we go forward here too.
I think they'll have to if they want to be successful.
Yeah. And then there was a question about, has there been any discussion in the open source community on how easily folks will be able to adapt to non-Hopper series GPUs? I haven't seen a ton. I was jumping into like our local llama and some of these like subreddits that are kind of focused on the hobbyist side, and saw people getting very excited about them, but I hadn't seen too much yet around adapting these. I might actually just, hopefully this is not a mistake, but I'm just going to pull up, I think it was this FlashMLA one where they've said, yeah, like so FlashMLA came out on Monday, and you already have a couple versions here of people that have added in, okay, for Meta X GPUs, there's a corresponding version that a community member made for these more threads GPUs. There's a corresponding kind of approach. So again, this is, I wouldn't know how to approach doing this, but it does seem like people are jumping on it pretty quickly. So hopefully like there'll be more of this coming through, and it won't be too difficult for people to convert some of these.
Yeah.
Yeah.
I think you and I were talking about that, John, earlier, of like, and maybe that's part of the plan, right? Of like, here's kind of what we did, and hoping that the community will kind of help them expand. That's always a benefit of open sourcing and getting the power of the AI community behind you.
Definitely. Cool. And then there's another comment as well, or question about how folks are evaluating the quality of their RAG pipelines between DeepSeek and OpenAI. Eduardo, thank you for this question, because this is like teeing up exactly what Arise can help with too, and Arise can do. So I'll make maybe a plug for some of the RAG evaluation tools and things like that. And Sarah, if you don't mind, if you could drop like our LLM evaluation guide in there, we'll kind of do a shameless plug for one of our resources. But we'll also let a bunch of other people respond and comment and dive into that, because that's a whole area as well. And I'd be curious for what other community members are doing. Cool. Thanks, Sarah. Okay. So that's what we had in DeepSeek. Who knows what we'll have over the next couple of days. Really exciting to see some of that going forward. And then the other two we wanted to talk about were Claude 3.7 Sonnet, as well as Claude Code. So can give a little bit of info about those. Claude 3.7 Sonnet is the newest version of Sonnet here. It's been billed as this hybrid reasoning model. So it's kind of an interesting architecture where it's not a pure reasoning model. It's not a sort of standard language model. It's kind of this hybrid reasoning model. And one very cool thing is that if you use Claude 3.7 Sonnet, the reasoning is visible. So unlike a O1 or O3 or some of these other models that kind of either hide or like do some modification to the reasoning, allegedly Sonnet will just spit out its full reasoning, and you can follow along with it as it's going. So they're actually making that visible, which is really cool from the Anthropic side. I mean, I think we had hypothesized on a previous paper reading that OpenAI was maybe not doing that with O1 because people could train off of that data in some way, and they weren't necessarily wanting to put that out to the world. So maybe Anthropic is not as worried about that, or maybe they're just being kind of more magnanimous here. So it is cool that 3.7 comes with visible reasoning here. And it is the same price as previous models. The main difference here being that you have to pay for the thinking tokens, the tokens that are used to output that reasoning. You do pay for those as well, but you do get kind of control over essentially how long the model will think. So you get this parameter of how like, the thinking time basically for a given request. So you are able to say, spend more time thinking about this. This is a simpler one. Spend less time thinking about that. So you can define that as you're going through. I pulled a couple of the benchmarks as well too. They really highlight its ability to do well on software engineering and kind of coding benchmarks. So they do kind of map it here against SweBench. So you do see that improvement. And then they also benchmark it for agentic tool use. And so again, they're showing improvement on that side as well too against O1. So they are seeing that as a pretty strong option there. And then I'll leave this up as we kind of talk through some pieces of it, but you can see more benchmarks across some different types of benchmarks that they have as well too. There's a really interesting note that they have in here that I think we can talk about a little bit later on too, which is that they're using more real world benchmarks as opposed to kind of standard benchmarks for some of these evaluations. So they have said, we're trying to use real world benchmarks that actually maps to what people are trying to do with these models, as opposed to just using standard kind of existing industry benchmarks. So that is an interesting note as well too. Sally, and I know we were talking before about how kind of Claude has become our go-to coding model as well too, and that's definitely the one that we end up using the most for some of that. Have you tried out 3.7? Are you excited to try it out?
I'm excited to try it out, and I'm excited to try it out because you have access to that reasoning, which, as you mentioned, you don't have with some of the other reasoning models that are out there. So I'm hacking on something for Copilot that requires a little bit of reasoning, and I was so frustrated by the fact that you can't access that like through the API. So I'm definitely going to be trying it out. So stay tuned for what we find.
And I saw some questions popping up too. Yeah, so question from Johnny here, which is, so is it like O1 or O3? I think it's a similar, like it's good to benchmark it against it because it has that reasoning capability, but they've sort of built it as this hybrid reasoning model. So the idea is it's almost like it can act as an O1 or O3, or it can act as a GPT-4o, depending on kind of like what the task is and how much you specify, like what you set the thinking time to be as well. And look through. Just note that it's crazy that we're at near 50% SWE benchmark when it was released in November, and now we're up to like 70% performances. So yeah, the performance of models on these benchmarks grows really quickly. I have my own kind of thought here that I think sometimes people build for improvement on these really well-known benchmarks. So there's a whole area too of, are these the right benchmarks? Are they indicative of real world usage? And I think in some cases they're closer to others. So I think the coding ones are probably a little bit more close to real world use cases. But it does raise a question as well too of are these benchmarks that we're looking at really the right ones that we need to do? And are we just going to have a new set of them once we've kind of maxed out these in some way?
I agree completely on that. I think that's been something we've been discussing for, I mean, I guess since the original GPT, right? Of like, are these even the right things to focus on? And I agree completely that for the most part, these don't really tell you how well it's going to do when you plug it into your application, building an agent. So I'm interested to see where the whole benchmarking data set and the topic goes.
Totally. All right. And I see some questions in there too around kind of benchmarking, or if people tried out Claude Sonnet, as well as if they've tried to add citations to a RAG application. So I'll let folks jump in on those things we keep going, and then we can tackle them at the end as well too. The last piece we wanted to highlight was Claude Code, which I think is very, very cool and played around with a little bit and is really kind of a unique form factor in a way. And basically what Claude Code is, for anyone who doesn't know, it's this command line tool for agentic coding. So you can essentially open up a command line window, open up a terminal window in some sort of directory, like your code base, and then you can essentially just prompt it as an agent. You can open up this Claude Code and prompt it as an agent. You can say things like, explain the code to me, everything from that to like large scale refactors, debugging. They show a lot of examples of adding tests. You can have it push to Git, you can have it kind of do whatever sort of coding task you want to have it take a shot at, and it will sometimes ask you permission to complete things, sometimes just go straight through with them as well too. And so the idea is it lets you kind of automate some of the boilerplate approaches. And I think of this like I know I use, and kind of a lot of folks on the Arise team, we use Cursor, or we use a similar tool to that, and there's sort of this like composer within Cursor. So I almost think of this as like its own kind of composer in a way that's operating in that more agentic kind of fashion as well. Sally, and I'll put it to you again. Any chance to play around with Claude Code yet? Are you excited about it? Do you think you'll use it, or do you think you're going to stick with what's happening in Cursor?
I'm definitely going to try it out. I'm really excited about it. I think everything that we covered just today, I think this is the thing I'm probably most excited to get my hands on. I haven't had the time yet to play with it. I don't think Cursor is going anywhere. They're honestly just crushing that experience. But I want to see what Claude Code can do.
Yeah, definitely. And then, yeah, this is just another graphic I pulled from their press release, which I thought was kind of interesting. This is how Anthropic's saying their release is going to be for the next few years as they move from kind of assisting to doing independent work, basically, and then eventually finding its own solutions and building its own kind of knowledge base as well. And then I know we're coming up towards our end here, so I'll breeze through a couple of takeaways and then maybe hit some of the last questions in the chat. But here in the takeaways that I jotted down were this hybrid reasoning model paradigm is interesting. I think it's a question of whether we see other providers adopting the strategy, because we kind of had our standard models and then we added in these reasoning models. And now we've almost come to this midpoint with this new release where you have a model that's both reasoning and kind of a standard LLM. And so curious if we'll see OpenAI and Mistral, others following suit here with their model creation. And then the form factor of agents was another one that we kind of talked about is, okay, I think there's still a little bit of figuring out exactly how people want to interact with agents, how agents can slot into workflows to make it really work well. So there's almost more like a product consideration here too of what does the experience look like to use one of these agents? And then as we talked about, the shift towards real world benchmarks. Awesome. And then I think that's all we had. I know there's some great discussion that's going on in the chat as well too. So maybe a couple things we can pull out of there with our last sort of couple minutes here. One note from Thilak, which was kind of talking about what we were saying about the benchmarks. I totally agree that that's the theme that we're seeing just for the recording as well. For anyone who can see that, the comment was that there's a pattern of a benchmark being released, we overfit to it and exhaust it, and then move on to the next one. And we need kind of more of a reliable, long-standing benchmark. And totally agree with that. I think that's really something that we're seeing. And then Johnny, to your point, humanity's last exam is an interesting option for this. I think my personal opinion is it's going to end up being a set of different benchmarks, and it's going to almost be these real world tasks as you have more ability for these systems to actually connect into real world use cases. So I think it'll be humanity's last exam plus a mixture of some other ones as well too. Yeah, and then to patch you, no Grok 3 mention. Elon Musk will be listening in. We didn't cover Grok 3 today. Maybe we'll save that for a future one. There's a bunch of different kind of pieces to cover there. So we'll save that for our next round. And a couple of last ones. Has anyone heard anything around ILIA's SSI since their inception? I haven't. If anyone's seen some new things, I've basically just seen the funding news more or less from that. So if anyone's seen more of what they're coming out with, please throw it in there. So I don't know if you've seen anything around ILIA's kind of SSI company that they founded and kind of created. I feel like I've just seen the funding so far.
Yeah, same. I
Yeah.
feel like that's all I've really seen come from that yet.
Yeah. So, awesome. And yeah, we're having some great other comments in there. Thanks everybody for listening in here. I know we're a little bit over time. Would really encourage everyone to keep the conversation going. We have our whole Slack community as well too. Sarah, I'm gonna put you on the spot if you have the link to that and you don't mind dropping it in the chat as well too. This has been some great discussion. We'll share out the slides here and then also in that community Slack. So would encourage everyone to jump in there too and we can kind of keep the conversation going as we go. Thanks everybody. Sally Ann, thank you for joining me. Really appreciate you hopping on here as well too as we go through. And with that, have a great day, everybody. We'll talk to you at the next one.